Welcome to Metrology lecture series. In the present video, we will discuss the advantages and limitations of mechanical comparators, basic principle of optical comparators, Zeiss ultra optimeter, and advantages and disadvantages of optical comparators. First, we will discuss the advantages of mechanical comparators. First one is the low cost. Mechanical comparators are usually cheaper than other types of comparators. Next one is no electricity is needed. Mechanical comparators do not require any external source of power supply or air as in the case of pneumatic or electrical comparators. Hence, outside sources do not affect the accuracy of the comparator. And next advantage is the linear scale. Installment of mechanical comparators usually have linear scale, which is easy to read. And next one is the easy to handle. Installment of mechanical comparators are usually robust and compact, so easy to handle. And last one is suitable for workshop. These instruments are portable and can be issued from storekeeper in workshop. Next we will discuss about the disadvantages of mechanical comparator. First one is the friction. Mechanical comparators are having the more moving linkages which is affect its accuracy. And next limitation is the inertia. So mechanical comparators have more inertia. Hence, these instruments are very sensitive to vibration which is affects its accuracy. And less accuracy is another disadvantage. So mechanical comparators have low accuracy due to the friction and high inertia. And next one is the wear play backlash. Wear play backlash or dimensional inaccuracy in the device used will also be magnified. This increases the error in measurement. And next one more limitation is the parallax error. They are affected with the error due to the parallax as the pointer moves over a fixed scale. And last one is the range is limited. So in general, mechanical comparators are having the limited range of measurement as the pointer moves over a fixed scale. So these are the comparison of the mechanical comparators. So next we have to move to the optical comparators. First we have to discuss about the working principle. In optical comparators, a basic optical principle is used. Instead of using a pointer, the shadow edge is projected onto a curved graduated scale to show the measurement difference. So in the optical comparators, we are not using the pointer. Instead of the pointer, shadow edge, which is the projecting onto a curve on a graduated scale, which is represents the differences between the workpiece and the standard specimen. So let's see the optical principle. The optical principle used is called the optical lever principle, which is represented in the figure. Here you have to observe. So here it is having the mirror. So when the ray of light OA, so this OA ray of light falls on a mirror, it is reflected ray of the AB in such a way that the angle of incident is equal to the angle of reflection. Here angle of incidence is the theta and angle of reflection also theta. So this will be occur when the mirror having the completely flat. So then angle of OAN, which is equal to the angle of the NAB. Now if the mirror is tilted through an angle alpha, so let's see here. So it is the tilted, that angle let's consider the alpha. So this is the mirror is tilted. Then the ray of light moves through an angle of the 2 alpha. So here reflected ray light moves through an angle of the 2 alpha. In optical comparators, the mirror is tilted due to the movement of the measurement plunger. This causes the reflected light beam to move and its movement is observed as an image on a screen. So this is the optical principle. Next we will discuss the mechanical optical comparators. So this is the schematic representation of the basic principle of mechanical optical comparators. So in the schematic you have to observe that one here. First a mechanical system, it is made of the pivoted lever. So here I have to see. First is the plunger is there. So we know that when the plunger is connected to the workpiece, if there is any differences or occur with respect to the standard workpiece, plunger has to be movement, so upward movements, and this plunger also connected to the pivoted lever. So due to these movements, so at the end of the lever which is connected to the mirror, so due to this movement of the plunger, this lever also move to the up and down movements. Then this will be caused to the deflections of the mirror. And so light has to be fall on the mirror which is projected on the pointer scale. Due to these movements of this lever, mirror also it has to the deflections has to be occur, and this has to be which is the projecting light has to be change its position. Due to this one it will be identify the errors. So let's see the basic principle. In a mechanical optical comparator, a small movement of the measuring plunger is first increased by a mechanical system which is made of pivoted levers. So first small movement of measuring plunger is increased by a mechanical system which is made by the pivoted levers. After that, movement is further enlarged by an optical system using light and image projection which has to be represented in the figure. So in the schematic you have to observe. So first we are increasing the magnification of the movement of plunger by mechanical system, that is the pivoted levels. After that one further once again you have to enlarging this magnification of the plunger movement by the optical system. The mechanical system causes a plane mirror to tilt about an axis. So this mechanical system which is the causing for the plane mirror to tilt about its axis. Due to this tilting, the image of an indexer is projected on a scale is placed on the inner surface of the ground glass screen. So this provides a large magnification of the small plunger movements. Next we will discuss the magnification of the mechanical optical comparators. We know that in the mechanical optical comparators, magnification of the plunger movement is increased by mechanical as well as the optical system. So first we have to see the mechanical amplification, that is the L2 by L1 which is by the lever rule. So here, so this mechanical system magnification is depend upon this L1 and L2, that is the L2 divided by L1. If the movement of the plunger causes the mirror to tilt by an angle of the alpha, then the image will be tilted by the 2 alpha. So therefore optical magnification which is equal to the 2 into L4 by L3. So this is the L4. So the length of from the pivot to the optical scale. So L4, and L3 is the So the distance between the pivot and the lever end. So which is contact at the mirror. This length we are calling as the L3. So optical magnification is the 2 into L4 by L3. Then overall magnification of the system is 2 into L2 by L1 into L4 by L3. Next we will discuss the Zeiss ultra optimeter. The Zeiss ultra optimeter is a type of mechanical optical comparators which is used to measure very small differences in dimensions with high accuracy. So this is the schematic representation of the Zeiss ultra optimeter. So it is the consisting of the mechanical system as well as the optical system. So mechanical system is consisting of the plunger which is contacting with the workpiece, and at the end of the plunger it is connected to the mirror 1. So this is the mechanical system. When there is a small differences with the standard workpiece, then plunger has to be movements, upward and the downward movements. Due to these upward and downward movements, this plunger has to be causes of the small tilt. Let's consider the alpha. So this is the mechanical system. Let's see the optical system. It is consisting of the light source of the lamp, so which is passing through the condenser, and it will be so falls on the mirror 1, then reflected to the mirror 2, and once again it causes for the reflection on the mirror 1, then once again it has to be reflection and light has to be reached to the eyepiece. So here multiple reflections are caused by the two errors. So there are the multiple reflections are there. Okay, let's see the brief details of this Zeiss ultrameter. So Zeiss ultrameter has to be gives higher magnification than ordinary mechanical optical comparators because it uses two mirrors and multiple reflections of the light. So there are the multiple reflections are possible cause of the two mirrors. In this instrument, a monochromatic light source passes through a condenser lens and an index with crosswires. The light then falls on a tilting mirror which is called as the mirror 1. So this mirror 1 we are calling as the tilting mirror. So first light has to be falls on this tilting mirror or the mirror 1. Then mirror 1 reflects the light to the mirror 2 which is placed parallel to it. Then once again mirror 2 again reflect the light back to the mirror 1. Thus the light is reflected several times which is increase the magnification. After these reflections, the light passes through an objective lens and forms a magnified image at the eyepiece through a transparent scale called as the graticule. The graticule scale helps in measuring the movement of the plunger. So let's see the working. So the working of the comparator is simple. When the size of the workpiece changes from the standard size, the plunger moves up and down. These up and down movements tilt the mirror 1 slightly. Due to this tilt, the image of the crosswires moves over the scale. The amount of movements on scale shows the deviation in the size of the workpiece. The instrument is enclosed in a protective PVC body and tubes to avoid dust and the damage. And moreover, a special screw is provided to set the reading to 0 before the measurement. After the setting 0, the readings may be positive and negative values. Positive indicates if the workpiece size is larger than the standard value. and negative if the workpiece size is smaller than the standard value. So then the Zeiss Ultra Optimeter provides an accurate and convenient method for inspection and precision measurement of components. Next we will discuss the magnification of Zeiss Ultra Optimeter. Magnification is defined as the movement of image divided by movement of plunger. So movement of plunger, so which is the h, height of the plunger, and let's see the movement of the image. First we have to see the what is the movement of the image. If the distance from the plunger center line to the first mirror pivot is x and the plunger moves a height h, then angular movement of the mirror, so dou theta equal to the h by x. So here let consider, so this is the x and this is the height h, and this tilt, let's consider the very small tilt, so dou theta, which is equal to the h by x. If the focal length of the lens, then the moment of the scale is 2f dou theta. So then moment of the image is the 2f into dou theta. So we know that when the dou theta equal to the h by x. Then moment of the scale, so our moment of the image is the 2f into h by x. So magnification is the moment of image divided by moment of plunger. So that is the moment of the scale divided by moment of the plunger. Moment of the scale which is equal to the 2f h by x, and moment of the plunger is the 1 by h. So here and h and the h will get cancelled. Then magnification of the Zeiss Ultra Optimeter is the 2f by x, and the overall magnification is the 2f by x into eyepiece magnification. Next we will discuss the advantages of optical comparators. First one is the high accuracy. Optical comparators have very few moving parts, therefore friction and wear are less, which helps in obtaining high accurate measurements. Next one is the no parallax error. The readings are taken using a projected image and datum line, so parallax error is eliminated. This also allows a larger measuring range. And next advantage is the high magnification. So optical systems provide very high magnification, making these comparators suitable for precision measurements and detection of very small dimensions variations. And next one is the weightless optical lever. The optical lever does not have physical weight like the mechanical levers. Hence, it reduces loading effect and improves sensitivity. Next one is the illuminated scale. The scale is illuminated, making it easy to take readings clearly under any room lighting condition. And next advantage is the high sensitivity. Even a very small movement of the plunger produces a noticeable movement of the image on the scale. And next one is the smooth operation. Since there are the fewer mechanical components, the operation is smooth and reliable. And next advantage is the suitable for precision inspection. So optical comparators are widely used in laboratories, tool rooms and precision engineering industries for accurate inspection work. Next we will discuss the disadvantages of optical comparators. First one is the, as the magnification is high, heat from the lamp, transformers, etc. may cause the setting the drift. Second one is the optical comparators depends on external electrical power supply. Next one is the operators use usually bulky and expensive. Next one is the, when the scale is projected on a screen, the instrument is to be used in dark room. And last one is, instrument is inconvenient for continuous use because the scale is to be viewed through the eyepiece. So these are the So disadvantage of optical comparators, and thank you.